All right, day 3 of your semester 1 final review. Starting with problem number 29, uh, using a graph to evaluate a function. So f of 1 means y when x equals 1. So we can go to the x value of 1, go up to our graph, then go to the left to find our y value. F of 4, same thing, our y value when x is 4. So go to 4 on the x-axis, go down to the graph in this case, go to the left, find your y value. C and D are yours to do on your own. Absolute value functions. Our general form, sometimes called vertex form, y equals a times the absolute value of x minus h plus k, where our vertex are the points hk. So h, you get the opposite of the sign that you see in the equation. K is the same sign that you see in the equation. A represents the slope of the right-hand side of the V shape for the absolute value. If A is positive, that V opens up like a regular V. And if we have negative A, it opens down like an upside down V. So finding the vertex for each function, I take the opposite of the value that's inside. So it's minus 4 inside. I'm going to put positive 4. And my y value is the exact same as what's on the outside, minus 7. Opposite of what's on the inside, positive 3 on the inside, becomes minus 3. Outside stays the same, positive 1 stays positive 1. Graphing. So my vertex, negative 1 on the inside becomes positive 1, plus 4 on the outside becomes positive 4. So over 1, up 4. There's my vertex. Once we have the vertex, we can ignore everything except the value for A, and that acts as a slope. So from my vertex, I go down to right 1, down to right 1, down to right 1, down to right 1. And then because of the symmetry, I get the same points if I go down to left 1. Shouldn't say the same points, but I get a new set of points if I go down to left 1 that are also on the absolute value function. And to graph that, there we go. So some key features of functions. An x-intercept is where the graph crosses the x-axis. Y-intercept, where the graph crosses the y-axis. A function has a minimum if it has a value that is less than all the other values, and that minimum value is the y value. A function has a maximum if it has a value that is greater than all other values, and that maximum value is the y value of the function. A function is increasing on an interval if the graph goes up as you move from left to right. A function is decreasing on an interval if the graph goes down as you move from left to right. The intervals in interval notation list the x values where the function starts and stops increasing or decreasing. And we always use parentheses for increasing and decreasing. So here we go. Number 31. Identify the x-intercepts and the y-intercepts of the graphs of the following function. So here we have an absolute value graph. X-intercepts, where it crosses the x-axis. -3, 0, and +5, 0. The y-intercept, 0, 3. 0, 3. Okay. This function definitely has a lowest point. That's a minimum. The minimum value is 4. And it occurs when x equals -3. Increasing and decreasing using interval notation. First of all, we'll notice that this function has a maximum. And that's important because that tells us this is the x value where it stops either increasing or decreasing. For the beginning, this graph is moving up as I move from left to right. That means it's increasing. It has an arrow on the left-hand side, which means it's increasing from -infinity to the x-coordinate of our maximum value, 1. And then it starts to decrease, and it decreases from 1. And again, we have that arrow at the end, so it goes to +infinity. And now our last unit, polynomials. To add polynomials, you combine like terms. The easiest way to do that, line up your terms vertically and in standard form, and place like terms below the like terms in the first polynomial. To subtract polynomials, change to addition by distributing a -1 to the second polynomial, or by adding the opposite. So the first thing I'm going to do to find this sum, so the big deal, it's a sum we're adding. I'm going to write this first polynomial in standard form. -7x to the 4th plus 6x to the 3rd minus 4x squared. And then line up my like terms. I have a 5x to the 4th. I have a -2 x to the 3rd, and I have a +8. So remember, you're lining up based on the exponent of the x. Once I have the like terms lined up, I can add or subtract the numbers in front. So -7x to the 4th plus 5x to the 4th, -7 plus 5 is -2, and we leave it as x to the 4th. 6x to the 3rd plus -2x to the 3rd. 6 plus -2 is +4, x to the 3rd. -4x, or -4x squared plus nothing is -4x squared. Nothing plus 8 is 8. And there is my answer in standard form. Here we have a subtraction problem. So again, I like to change subtraction to addition of the opposite. Again, my first polynomial, I'm just going to write in standard form. 7x to the 4th plus 4x to the 3rd minus 3. My second polynomial, once I've changed my signs, I have a -5 x to the 4th, a -8 x to the 3rd, and a -8 x. They were all positive. Once I changed subtraction to addition, they all became negative. Now add 7x to the 4th plus -5x to the 4th is +2 x to the 4th. -4x to the 3rd, I'm sorry, That's positive 4x to the third. Plus negative 8x to the third gives me a minus 4x to the third. Nothing plus negative 8x is negative 8x. Negative 3 plus nothing is negative 3. Multiplying polynomials. So big thing, remember that power rule? If I have x to a power of m times x to a power of n, I add my exponents. To multiply a monomial times a polynomial, use the distributive property. If we have two binomials, a two-term times a two-term, we can either use the box or FOIL methods. And to multiply a binomial and a trinomial, I find it easiest to use the box method, but you could also use the FOIL method. If we run into an example here, I will use the box method. All right, so here, 36a, we have a monomial times a polynomial. So I'm going to distribute. Very simply, I multiply the numbers in front. 5 times 2 is 10. And then for the x, I add my exponents. 2 plus 3 is 5. 5 times minus 4 is minus 20. X, 2 plus 2 is 4. 5 times minus 8 is minus 40. I have x, I have a 2. Over here, my exponent is 1. 2 plus 1 is 3. Here I have a binomial times a binomial. I'm going to use the FOIL method on this one. FOIL stands for first. So 3x times 2x. 3 times 2 is 6. X to the first times x to the first is x squared. Then the outer, 3x times minus 7. 3 times negative 7 is negative 21. And that has an x. Inner, 5 times 2x is plus 10x. And lasts, 5 times minus 7 is negative 35. With FOIL, I have my like terms right next to each other. So I have 6x squared minus 11x minus 35. Here I have a binomial times a trinomial. So I will use the box so you get to see an example of the box method. Again, I'm going to write that trinomial across the top of my box. 5x squared minus x plus 6. And down the side, 2x plus 3. Now I take my 2x times my 5x squared. 2 times 5 is 10. Again, that 2x is like 2x to the first. Add my exponents. X squared times x to the first is x to the third. 2x times minus x. Again, that's like a minus x to the first. 2 times that negative 1 is negative 2. X times x is x squared. 2x times 6 is positive 12x. Across the bottom, 3 times 5x squared is positive 15x squared. 3 times negative x is negative 3x, and 3 times 6 is 18. Like terms, again, happen to be diagonally across from those circles. So I have 15x squared minus 2x squared. 15 minus 2 is 13. X squared. Again, the x doesn't change exponents when you're adding or subtracting, only when multiplying or dividing. I also have a minus 3x plus 12x. Negative 3x plus 12x gives me a positive 9x. And here's my answer. I'm going to rewrite it. 10x to the third plus 13x squared plus 9x plus 18 using the box method. Special cases, one of the last things we talked about. And there is a formula for the square of a binomial. Again, as it says at the top, you can use the formulas or you could use box or FOIL method, whichever you're most comfortable with. I will show with the formulas. Again, I'll leave it up to you to decide which method you use. So this is a binomial squared. The formula says I take my first term, 5n, and I square it, plus 2 times my first term times my second term. Now, careful here because the second term is negative 7. That negative does stay with the 7, plus the second term squared. For 5n squared, I take 5n times 5n. 5 times 5 is 25. N times n is n squared. For my next term, I take 2 times 5n. That would be 10n times negative 7, negative 70n. And the last term, I square negative 7. Negative 7 times negative 7 is positive 49. And there is my square of a binomial. Here we have the sum and difference, sometimes called a conjugate pair. Same thing. The formula says I take my first term squared minus my second term squared. 2x squared would be 2 times 2 is 4, x squared minus 5 squared is 25. Again, you could use box or FOIL or memorize the formula. That is all for your day 3 of your review. Good luck on your finals, and I'll see you in class.